Every computer system has an arithmetic and logic unit. That arithmetic and logic unit is great at adding numbers together in binary, using binary adders and half adders, but one thing it cannot do directly is it cannot subtract. Now let's take a look at how it will conceptually change something into an addition, which it's good at, from a subtraction. So if we look over here, I'm going to use simple numbers. 5 subtract 3 can be thought of as 5 subtract positive 3 or 5 plus negative 3. So the concept is we can take a subtraction and turn it into addition if the number that we're adding is the negative of the original value. Now how does it generate that negative? Well, let's take a look. If we have this as a number and this is a different number now, we're using the number A5. And if we want to subtract A5 from something, we can't do it directly as it says here. What we have to do is change it to something called a 2's complement. And the way that happens is computers in the arithmetic and logic unit have inverters. So the first thing it does is it runs this number through 8 inverters. And each inverter changes the number from 1 to 0 and 0 to 1 to generate what's called a 1's complement. Now if you were to take this 1's complement number here and add it back to the original, you will get all 1's. So let's take a look at this. So we take this number, which is our 1's complement, we add 1 to it, and we get something called the 2's complement. Now this 2's complement, like the subtract positive 3, add negative 3, this is the opposite of the original number, as we'll see in terms of sign. And the way we can figure that out is if we take this 2's complement and we add it to the original number, we get 0. And the only way you can get 0 is if you take this number and add it to the negative equivalent of that value. And that's what we've done, is we've been able to take something where we said subtract positive 3, we want to add the negative of that. What we're doing here is we can add the negative, in this case, of A5, which in our case happens to be 5b. So this is one possible example of how it comes up with a number. Now let's see how it's used in a practical situation. So if we look here, if we have this subtraction, which is BA subtract EF, and what we can do is again change all these 1's to 0's, 0's to 1's using inverters, and that will give us our 1's complement. If we add 1 to that, that generates our 2's complement, which is the negative of this. So this number here, EF, its 2's complement or negative is 1, 1. So if we add these two numbers together, then we're going to get our proper result. However, there's one gotcha. And that is this, is that when you're doing a subtraction, the carry is set one way. If you do the equivalent addition, it's set the opposite way. So even though this will generate our proper 8-bit answer, one of the things we have to do is invert the carry to get the appropriate carry for the original subtraction. We can do the similar operation of this in hex. As I said, this is BA minus EF. So what we want to do is figure out a way to generate the 2's complement of EF. And the way we do that in hex is quite simple. We take FF and subtract EF to get 1, 0. And that becomes the 1's complement. And what that means is if we add 1, 0 to EF, we get FF, and that's typical of how 1's complements work. 1's complement added to itself will generate all 1's, or in this case FF. Then if we add 1 to that, it's going to give us 1, 1. And so our original subtraction here is BA minus EF, which is equivalent to BA plus 1, 1. And if we add these, it's very easy to add. BA plus 1, 1 is CB, and that will give us our answer here. But again, the carry's messed up, and we're going to have to invert the carry to give us the appropriate value. Now, as it says here, it's not intuitive what it's done because it's using digital circuitry, and digital circuitry is definitely not intuitive. What we're going to look at next is how to do this same operation and make it intuitive based on what we learned in public school. And what we're going to find is that that intuitive way of doing subtractions is going to be easier than doing hex additions. So we'll look at that next.